Around the world, many people use GPS or global positioning technology to get from point to point more easily and quickly, including many who are driving farm and mining equipment, thanks to a group of Stanford University and NASA researchers. In 1984, the team worked together on NASA's Gravity Probe B mission. The mission was designed to test a couple of Einstein's relativity predictions.
If you put something in space and put it in orbit around the Earth, you could make the gyroscope drag-free, gravity-free, and take away all the forces affecting that gyroscope, and then just make these measurements of the theory of relativity.
For the mission's experiments, the Stanford group developed new high-performance attitude-determining hardware that relied on GPS signals. The hardware determined the spacecraft's precise orbit location and attitude. While working with NASA, the university team thought their technology probably would have other flight applications and tested it on a small passenger plane. The Stanford researchers formed a company, Integranautics, now known as Novariant Incorporated, and partnered with engineers at NASA's Langley Research Center and the Federal Aviation Administration to develop one of those applications. Through a small business technology transfer, or STTR, contract from Langley, the firm built an integrity beacon landing system capable of landing aircraft.
If you could use carrier phase to measure small differences between the wings of an airplane, well, what if you took an antenna on the ground somewhere? Could you actually measure the position of that airplane as it were, say, coming in for a landing?
By using the new system, Novariant was able to conduct automatic landings with a Boeing 737. The Integrity Beacon Landing System had centimeter-accurate real-time kinematic, or RTK, GPS technology, as well as pseudolight infrastructure, a first for aviation. The pseudolights, acting as GPS transmitters on the ground, built in position redundancy for the plane. Because of the successful 737 landings and some other Stanford research, Novariant believed the system could provide precision control of other vehicles, including farm equipment. By tweaking the original technology, Novariant created a new technology they actually tested in farmers' fields.
Before we knew it, the farm owner would be coming up to the tractor. They'd see what we were doing and would start asking a lot of questions. And usually that conversation would end with the farmer breaking out his checkbook and saying, "I've got to have that thing."
The company made their original prototype much smaller and simpler to use, and in 2000, they released RTK AutoSteer through its new AutoFarm division. Today, farmers around the world are using AutoSteer to get sub-inch accurate steerings from their equipment when they're preparing fields, laying beds, planting, and tilling. Another application also spun out of the original NASA STTR work. Novariant has commercialized the pseudolights, now called Terralights, for open-pit mining applications.
Many of these mines are using GPS today. Now the problem is, as you dig a big hole in the ground, the walls of the mine will block the GPS signals. In other words, you don't have a clear view of the sky if you're in the bottom of an open pit. So what we do is we provide these Terralights. The Terralights go around the rim of the mine, and they provide extra signals into the mine so that the vehicles can perform their position fixes and do their job 24 hours a day, 7 days a week.
In the future, maybe AutoSteer will be steering a NASA vehicle in space.